Hello students, welcome to EPG Pathshala. I am Dr. Vishal from Maharaja Agarsen University, Badi, Himachal Pradesh. Today, we are going to discuss about the module Project Appraisal in terms of technical analysis under the paper Entrepreneurship, Development and Project Management. After completing this module, students, you will be able to understand the meaning and concept of technical analysis, understand the techniques to be applied for technical analysis, and know about various aspects of study under technical appraisal. Project appraisal is a process of detailed examination of several aspects to a given project before recommending the same. After market and demand analysis, there is a need for further suitability of the project as to whether it is feasible or viable in other dimensions so that the project idea is put to acid test of cold facts before it is accepted for formulation and implementations. So there is a need for feasibility studies which include market feasibility, technical feasibility, economic feasibility, managerial feasibility and commercial feasibility. Therefore, feasibility study is the process of investigating a problem and finding a solution in depth to determine its economic viability and worth of development. Project feasibility is a test where prima facie viability of the project is evaluated. Technical analysis seeks to determine whether the prerequisites for successful commissioning of the project have been considered and reasonably good choices have been made with respect to location, size, etc. It is carried out to measure whether the project is technically sound and viable. Technical analysis of a project is very essential to ensure that necessary physical facilities required for production will be sufficient and the best possible alternative is selected to procure them. A technical analysis should review the techniques to be applied and should incorporate
a description of the product, including specification relating to its physical, mechanical, and chemical properties, as well as the uses of the product. A description of the selected manufacturing processes showing detailed flow charts and presenting alternative processes which may have been considered and the justification for the adoption of the selected process. A determination of the plant size and the production schedule. Selection of machinery and equipment. Identification of plants, location, and as assessments of its desirability in terms of its distance from raw material sources and markets. A design of the plant layout and an estimate of the cost of the erection of the proposed buildings and land improvements. A study of the availability of raw materials and utilities, including a description of physical and chemical properties, quantities needed, current and prospective costs, terms of payment, location of sources of supply, and continuity of supply. An estimate of labor requirements, including a detailed breakdown of direct and indirect labor requirement, and the supervision required for the manufacture of the product. A determination of the type and quantity of waste to be disposed of, together with the description of the waste method, its costs, and the necessary clearance from proper authorities. An estimate of the production cost of the product. Technical appraisal. Technical feasibility assesses the technical viability for coming to a conclusion as to whether it fulfills the expected norms or not. Technical appraisal involves the critical study of following aspects: material inputs and utilities. This aspect is concerned with defining the materials and utilities required, specifying their properties in detail, and setting up their supply program. Material inputs and utilities may be classified into four broad categories such as raw materials, processed industrial materials and components, auxiliary materials and factory supply, and utilities. Raw materials. It may be full or semi-processed. It can be further grouped into agricultural products, mineral products, livestock and forest products, marine products. Processed industrial material and components. Processed industrial material and components represent important inputs for a number of industries that include base metals, semi-processed metals, manufacturing parts, components, and sub-assemblies. To get authentic and sufficient information, answer of the following questions must be sought. What are their properties? Physical, mechanical, chemical, and electrical? What are the domestic sources? What are the foreign sources subject to limit laid down by the authorities? Extent of dependability on supplies and suppliers? What has been the price trend in the past? What will be the future trend? Auxiliary materials and factory supply. Any manufacturing project needs variety of auxiliary materials and factory supplies like chemicals, additives, packaging materials, paints, varnishes, oil, grease, cleaning materials, consumable stores. In addition, the first two categories of materials. Utilities. Utilities stand for power, water, steam, fuel, gas, which play a constructive role in converting raw materials into end products. Correct assessment of these in terms of location, technology, plant capacity, and the like is a must. These utilities turn critical at times and become limiting factor in achieving highest level of efficiency or lowest level of cost. Manufacturing process or technology. The methodology used in converting materials into final products is known as a technology. For manufacturing a product, there are alternative technologies. To manufacture steel, either open hell process or Bessemer process can be used. That represents a technology. In making cement, the possible process are wet or dry. These technologies always changing from good to better and from better to best. Even what is today, the best can be supposed in case better than the best is made available. Research and development efforts make possible the best because even the very best can be improved upon a period of time. Feasibility study, especially technical, is to focus its attention on the significant aspects of choice of technology, acquisition of technology, and the appropriateness of the technology. Choice of technology. The choice of technology or technical know-how is influenced by many variables. Some of these are plant capacity. Plant capacity and manufacturing technology are closely related with one another. In order to meet a given plant capacity requirement, only a specific production technology may be viable. Investment outlay and production cost. The impact of alternative technologies on invest expenditure and production cost should be carefully assessed over a period of time. As we all know, cost and technology are closely related in that the cost and quality is based on technology and that is based on its cost. Major inputs. Basic inputs play significant role in choosing a manufacturing technology. For example, in manufacturing of cement, the quality of limestone decides whether the manufacturing unit should go in for wet or dry processing. Proof of success. The technology adopted must well be proven by its success for use by other units. That is, a latest technology may not be always the best. One which is tried, tested, and trusted by successful units in the line is more acceptable. Latest advancement. The technology adopted is one which is the latest or which is adaptable for updating easily with least cost and time. The product mix. Product mix stands for the main products, co-products and byproducts that are resulting by use of a particular technology. Ease of absorption. Technology, however latest and effective, has no meaning unless it is easier to be absorbed by the company. Very often, it so happens that high-level technology may not easily percolating to the absorbing firm due to some reason or reasons.
Acquiring technology. If technology is available openly, then the detailed information can be obtained even at feasibility stage. In case the know-how available with the owner, then this step, that is evaluation of process, can altogether be eliminated. And if the know-how is not available with the owner, it has to be acquired from outside sources such as foreign collaborators, consultancy organizations, machinery suppliers, promoters' knowledge and experience, and recruitment of suitable personnel. The acquisition of technology from some other enterprise may be possible through
Technology licensing. This is the most popular way of acquiring technology. Under this arrangement, the technology license gives the licensee the right to use the patented technology and get the concerned know-how on a mutually agreed basis. The supplier of technology generally provides a technology package which may consist of some components which are not essential. Therefore, it becomes essential to break the package into component parts such as technology, proper engineering services, supply of intermediate products, and supply of equipment by the licensor, use of the trade name, among the other things. Every effort should be made to acquire only the essential and matching components of the technology package. The contract for technology licensing should be careful with regard to definition of technology to be acquired, cost of technology licensing, guarantee provided by the licensor, duration of the technology licensing, and purchase of intermediate products, components, and other related inputs. Outright purchase of technology. This alternative is most appropriate when there is no possibility of significant improvement in technology in the foreseeable future. There is hardly any need for technological support from the seller of the technology. Joint venture arrangement. This is also a very popular method under which the supplier of the technology may participate technically as well as financially in the project. Financial participation is normally in the form of equity holding. Experts are of the opinion that financial participation is likely to strengthen the motivation of technology supplier to transfer improvements without hesitation.
Appropriateness of technology. Appropriate technology means for those methods of production or process of production which are most fitting to the local, economic, social, cultural, environmental conditions, etc. Technology should be considered appropriate if it satisfies the following questions: whether the technology uses the local raw materials, whether the technology employs the services of local labor force, whether the goods and services produced cater to the basic needs, whether the technology protects and maintains the ecological balance, whether the technology is in harmony with the social and cultural values of the area. Product mix. The choice of product mix is guided by market requirement. Variations in size and quality of products are aimed here at satisfying a broad range of customers. It enables a company to expand its market and enjoy higher profitability. There should be a degree of flexibility in the product mix to respond as to changing market conditions and thereby enhancing the power of the firm to survive and grow under different situations. Product mix is so designed as to meet the requirements of target market or segments of the entire market for the company's products and services. All other mixes, namely price, place, and promotion mix, go in consonance in a congruous way in requirements of a product mix. For example, a ready garment manufacturer of ladies' suits will have a wide range of items of size and quality to suit individual differences in customers, both physical and mental. Wide range of sizes, patterns, and quality play a significant role in enabling to garment maker to earn good profit through higher profitability. Thus, each company comes out with different sizes, different colors, variations in inputs, and packing and promotion packages. These varieties meet the requirement of poor, middle, and rich class. The idea is to arrive at maximum profit.
Plant capacity or production capacity. Plant capacity or production capacity refers to the number of units that can be manufactured during a given period. According to the experts, plant capacity is defined in two ways, namely feasible normal capacity and normal maximum capacity. The feasible normal capacity stands for the capacity attainable under normal working conditions. This is established on the basis of installed capacity, technical conditions of the plant, normal stoppages, downtime for maintenance and tool changes, holidays and shift patterns. Whereas normal maximum capacity is the capacity which is technically attainable, and this normally corresponds to the installed capacity guaranteed by the supplier of the plant. Manpower requirement. Requirement of manpower of different skills both for construction stage and operational stage should be assessed based on phasing of project execution and completion. The requirement of people should be assessed category, operation and function wise. The assistance of consultancy company for recruitment of staff with the desired skills and qualification may be sought if needed. The object should be to ensure the availability of adequate manpower for future operation and to avoid overstaffing at any stage of project execution. Adequate provision for fund for the training of key personnel with the time-bound program should be estimated beforehand. The introduction of scheme of productivity linked incentive or bonus may be kept in mind. Plant location and site. Location refers to a fairly broad area like city, an industrial zone or a coastal zone, and site refers to a specific piece of land where the project would be set up. Plant location includes selection of a requisite region, credible community and suitable site. Selection of region is a broad decision. For selection of proper site, a survey may be conducted and both Monetary and non-monetary factors should be looked into. The choice of location influenced by a variety of considerations such as raw material supplies, proximity of supplies, communication and transport facilities, manpower, labor laws, and government policy, taxes and fees, etc. After selecting of region, the next step is to selection of a particular community or locality. The selection of a community or locality calls for rigorous factors like quality and quantity of labor force, banking and credit facilities, local taxes, rents, rates and insurance charges, political stability, extent of state assistance, and many more. The final round selection is selection of site or space where industrial plant is going to be located. The important factors that decide the choice of suitable site are price of land, the type of choice, ease of waste disposal, people's attitude, existence of religious and social institutions, etc. Taking all these factors, the most advantageous location is that where the cost of gathering material and fabricating it, plus the cost of distributing the finished product to the consumer, is the least.
Machinery and equipments. It is the technology that determines the exact requirement of machinery and plant capacity. It is also influenced by the type of project. For a process, industrial plants, say petrochemical unit or pharmaceutical unit, the machineries and equipment required should be such that the various stages of manufacture are matched well. To determine the kind of machinery and equipment required for a manufacturing industrial plants, the following procedure is generally followed. Estimate the likely levels of production over given period of time. Define various machines and operations. Calculate machine hours required for each type of operation. Select machineries and equipments required for each function. The equipment required for the project may be classified into the following types: mechanical equipments, plant or process equipments, electrical equipments, instruments, controls, internal transportation system, and earth moving and construction equipment and others. While selecting machines and equipments, some possible constraints should be kept in mind, like shortfall of electricity, lack of cooperation on the part of employees when they are meant to advance technology, or numerical control of machines, hurdles in moving equipment or divided plant to remote places.
Structure and civil work. For the proper execution of civil work in the proposed project, the essential steps are defining scope of work with respect to site preparation, construction of roads and buildings in factory, and residential areas and construction of sewerage line and other civil works. Preparing cost estimates. Selecting agencies to be hired for construction. Preparing plans, charts, and drawings. Civil work can be further divided. Site preparation and development. This involves a set of activities, namely grading and leveling of site, demolition and removal of existing unwanted structures, relocation of existing pipelines, cables, roads, power lines, reclamation of swamps and draining and removal of stagnant water, connection of utilities from the site to the public network, electric power, both high tension and low tension, water for drinking and various industrial purposes, communications, telephones, telex, roadways, railways, and other activities of site preparation and development. Buildings and structures. It includes factory or process buildings, ancillary buildings required for stores, warehouses, laboratories, utility supply centers, maintenance services, and others. Administrative buildings, staff welfare buildings, cafeteria, medical center, gymkhana facilities, recreational buildings, and residential buildings. Outdoor works. The outdoor works involves supplies and distribution of utilities such as water, electricity, steam, gas, communication, and the like. Handling and treatment of emission, wastage, and effluents. Transportation and traffic arrangements such as roads, rail tracks, paths, parking areas, sheds, garages, traffic signals, and so on. Outdoor lighting, landscaping, and enclosure and supervision that include boundary wall, fencing barriers, gates, doors, security posts, sewerage openings, and the like. Project charts and layouts. When data is collected on major dimension of project, that is on market size, plant capacity, production technology, machines and equipments, building and civil works, then project chart and layouts are prepared. These charts and layouts define the scope of the project and provide the basis for detailed project engineering and estimation of investment and production costs. General functional layout, transport, utility consumption, communication, organization, plant material flow, and production line diagram are the major charts and layouts. General function layout. It shows the general relationship between equipments, building, and civil work. Utility consumption diagram. It shows the principal consumption points of utilities and their required qualities and quantities. Transport layouts. It shows the distances and means of transport outside the production line. Communication layouts. It shows how the various parts of the project will be connected with telephone, telex, intercom, and fax, etc. Plant layouts. It shows the physical layout of the factory, equipments, dimensions, provision for material handling, level of computerization, nature of process, etc. Due to consideration should be given while preparing a plant layouts to the followings. Consistency with production technology. Effective use of space. Flexibility to take care future changes. Smooth flow of goods from one workstation to another or one stage to another. Safety to the workforce. minimization of costs, provision for better working conditions to enhance efficiency. Material flow diagram. It shows flow of materials, utilities, intermediate products, final products, byproducts, and emissions. Production line diagrams. It shows how the production would progress along with the key information for main equipments. Organizational layouts. It shows the organizational setup of the project along with the information on personnel required for various departments and their interrelationship, even reaching grassroots level of each work position. Work schedule. Work schedule is the plan of the work relating to installation and initial operation. The purpose of the work schedule is to anticipate problems likely to arise during the installation phase and suggest possible means for coping with them. Establish the phasing of investments, taking into account the availability of finances. Develop a plan of operations covering the initial period. So, in order to avoid the possible losses arising out of idle plant capacity or idle capacity and the determination of stock material, work schedule should be drawn in detail with clarity and ground realities. This helps in making use of available inputs by adjusting plant capacity utilization or at least commissioning to start with.
So students, let's now summarize what we have learned in this module. Project appraisal is the assessment of a project in terms of economic, social, commercial, ecological, and financial viability. The technical feasibility assesses the technical viability for coming to a conclusion as to whether it fulfills the expected norms or not. Technical analysis seeks to determine whether the prerequisites for successful commissioning of the project have been considered and reasonably good choices have been made with respect to location, size, etc. It is carried out to measure whether the project is technically sound and viable. Technical analysis of a project is very essential to ensure that the necessary physical facilities required for production will be sufficient and the best possible alternative is selected to procure them. So, technical appraisal plays a very crucial role in acceptance or rejection of a project because a project which is not technically viable will not be financed by the lending institutions. Thank you very much.